right, so we have this bank account starting it out with $1,000. Then we're depositing how much? We're depositing another $1,000. So now we have 2,000 in there. And so now we want to print 2,000. So the first option prints 1,000, so that can't be it. The second option prints 2,000, so that looks good. What's the difference between the second and the third? Oh, no semicolon. So this better be the right option. All right, let me submit my answers. Yeah, I know. Oh, I see. All right, so I'm correct here. Why is it 2,000? Let me blow this up so that you can really see. So the bank account starts out with $1,000. And then here we're making a call to get balance. So what does this call return? The call to get balance says what is the current balance. I started out with $1,000, so the current balance is $1,000. Right, so this quantity here is 1,000. And so after that call, I'm now calling account.deposit of 1,000. I already had $1,000 in it. I deposit another $1,000, and so now the balance is 2,000. Yes? Okay, talk to me after class. So does that clarify this question? So it's what this question really tested is, can you carry out one step at a time from what the program actually says? It's not necessarily a very meaningful thing. I mean, when is the last time you went to your bank, said, how much money do I have in my account? And then said, oh, I'll deposit this much money again. I mean, it's not something that one does in everyday life. But that's what the code said for whatever reason, and that's what you had to trace through. So this was just a question of can you trace through a program and see a step at a time what it does. So the key observation here is that you need to ask yourself, what is this number? It's a method call, it returns a number, and whatever that number is gets stuck into the next method call, whether it makes sense or not. All right. Other questions? Okay, on that same line, I would like to go through a couple of things that I saw in Piazza. There were like very typical things where people who start out where they do the wrong thing. And so I'm going to put up some actual code from actual people, and I'm not trying to make them feel bad or anything. These are very typical beginners' issues, and I just want to point out how one can debug those issues if you don't happen to have Piazza ready. Like, for example, in an exam, you might be in a situation like this, and clearly in an exam, you cannot go to Piazza and say, hey, I'm having this problem in my exam. Can one of you guys help me out, right? There you have to be able to do it yourself. And also, as I read through some of these issues that some of you had, I looked at the code and said, oh, yeah, that's wrong. And I knew because I knew the right answer. And it occurred to me that if you don't really know the right answer, it's not so clear how do you progress. And so let me tell you how one does this in a somewhat systematic way. So I'm going to kind of randomly pick a problem that someone had with somewhere in 3B. Okay, come on, Piazza. There we go. So I'm going to try not to show the name. Not that it matters. Like I say, it's a perfectly natural thing to do wrong the first time. So let me take this code out and put it into BlueJ. Okay, well, come on. Here. All right, so here we have this class here, and first of all, there's a neat trick in BlueJ. There is a way of reformatting everything. If you go to Auto Layout, then it formats everything nicely. So it's always a good idea to do, particularly when you copy code from somewhere. Usually when I do this, there's at least one person in the audience who says, "Now you tell me." So I'm going to assume that someone just said that. So let's look at this particular class. So when I look at a class like this, then the first thing I notice is, so we look at the overall structure, which is fine, right? There's a move method, there's a turn method, there's a get position method. And then I look at the instance variables. And the problem with the instance variables is what? Yeah, the names are the same as the methods, right? And that doesn't normally happen like that. What's kind of common is that when you have a method that says get something, like over here, and it doesn't do anything other than fetch an instance variable, then it's very common that the name of that variable matches the name of the getter. So I would kind of imagine this thing here should probably be called position. And then also when I look at the instance variables, I don't really know what it means. If I have a bug where move is 5, turn is 3, and bug is 6, it's not at all clear to me what that would mean. So the instance variables are supposed to describe what the bug remembers. And so what the bug needs to remember, of course, is its position and its direction. And so position and direction would be better instance variables. So it would probably be a good idea to rename these. So let me do that really quick. In NetBeans, there's a way of automatically renaming variables. Unfortunately, in BlueJ, it's not quite as automatic. So I have to do it by hand. This kind of funny dialogue here. So I want to change the bug to position. But not all of them, because not this one over here, for example. So I want to change this one here. Okay, how the heck do I skip? Next. Oh, yeah, here. So I want to change this one. Skip this one, this one, this one. Okay, all right, that was that. So now the position is okay. So let's see what's the turn. I hit Control F, but if you do edit, it's here somewhere. Tools, fine. Okay, here it is. And apparently Control R gives you the replace right away, but there was like a replace doohickey here that I typed. Yeah, actually BlueJ is so simple that it's probably worth your while just going through all of the menu options and see what they do. All right, so now let's try to figure out what move is supposed to do. Or turn, I think turn is, yeah, okay, here we see that turn is the thing where it says 1 is facing right, -1 is facing left. So the comment here is good. That helps me understanding what it's supposed to mean. Just that turn is a poor name for it. So I guess a good idea would be to change it into, any suggestion? Direction, I think is, so. Yeah, turn is the name of the method. It's possible to have a name of the method and the name of the variable identical. It's not illegal, but it's very strange. It's not something. Right, so method names, what he says, and that's a very good observation, that method names are generally verbs, and that the names of variables are typically nouns or adjectives. And so it's unlikely that they would really be the same. All right, so let me change turn to direction again. I'll do something else with move in just a minute. Because I'll okay, so, oh wait, here it's direction. All right, and now there's the question, now there's a third one, that's turn. Oh, I see what you said down here, I messed it up, okay. Okay, there's turn and move. I want to get rid of move, and I want to explain why I didn't like move. Now I understand what you said, sorry about that. So over here we have move, and that now adds this quantity, but really, that's not what I want. I want it so that when the direction is 1, I add 1. When the direction is -1, I subtract 1. So over here, I want the direction. And when you turn, do you change the position? You don't, right? You stay on the one spot. So over here, you really don't. So, and now we have this extra variable that now no longer fulfills any useful purpose, and one should just remove it. So this happens when someone starts out with a very hazy feeling for what the instance variables are. And so one can sometimes, like in this example, kind of gradually refine that by taking the ones that make some sense, giving them good names, and then visiting each method and see what happens in each of the methods. So at this point here, I'm reasonably sure that this bug is going to work out fine. And so if you find that your instance variables seem pretty randomly named, you need to come up with better names for them. You need to have some idea of what they describe. And again, what's the visual here? So when you have the bug crawls along this line here, it faces a particular direction, and it's at a particular position. This here tells you what the position is, and the direction is either +1 if it's like this, or it's -1 if it's like that. Say again? Can you reuse? I don't get it. Why would you reuse them?
Well, like if you have just like 3 or 4 different bank account classes and you use the same name for the
Oh yes. So if you for whatever reason have a bank account class that has a balance, and then you have a kitchen scale class that also has a balance, they're independent of each other. They're private after all, so the outside world doesn't know what they are. You can give them any names you want. So you could perfectly well call them turn and move. It just makes your code really hard to read if you give them unintuitive names. So it's not a recommended thing. On the other hand, like for an exam, this sometimes happens. You might have a public class mystery where it says private enigma, and you have a method that says public void, what does it do? And in that case, you would just have to trace through it by hand. And that brings me to the next thing that I want to do. So there was another one that was closer to a good answer, but it contained a subtle bug. Let's see if I can find that. Come on, Piazza. All right. So this was a bug 2. And again, a very common situation for someone who's just starting out. So here we see the state now is what you would expect for bug 2. We have the x and y position and the x and the direction in which it moves. The direction could be one of 4 things. The move method here is fine. It was like the way that I showed it in class, and it has maybe a little bit verbose here, but it'll work fine. The turn method when I looked at it, was also fine. It's pretty verbose. So it computes nu dx as dx dy. Then it changes its mind and says, oh, I actually mean dy minus dx. That's not a mistake. It'll run correctly. It's not very elegant. So if you look at the first assignment, those values are never used. So one could just omit those, and I'm going to do that for clarity. So now the code is more the way I imagined it. And so that one is correct. The get x and get y are correct. Yet the person said, when you run it, it doesn't give the right answer. And so I'll give you a recipe of what you can do in such a situation. And it's actually very simple. What you want to do is you want to trace through the code a step at a time. So let's see through which code we're tracing. That would be the bug tester. So let's run this one here. Guess I need to compile this one. That's no good. That must have picked up the old class. Come on. So it passed this one, and here it went wrong, right? So it had a 1 and expected 0. So now we do have to kind of laboriously run this through, but here's how you do it. So we get out a sheet of paper. We draw a table where you write down the settings of the instance variables. So we have these 4 variables. And let's look at the code here. So we're making a bug 2. So that means we run the regular constructor, the constructor with no parameters. That's the one here. And so it sets 0, 0, 1, 1. Okay, let's remember that. 0, 0, 1. Then bug tester runs. And it calls getX, getY. Okay, that doesn't do anything. We call move. So now let's go through move and see what move exactly does. Move comes up with 2 variables, new x and, it's with 1 variable, new x. So let's see what new x is. And it says new x is x plus dx. Here's x plus dx, so new x is 1. Then it says x equals new x. So that means x has now changed to the 1 over here. Now it says y equals y plus dy. So y plus dy is 0 plus 1, and now y is 1. All right, so that's what it actually did, and the way you get that is by making this table here. Now, making these tables that trace through the code is a very important skill, and it is something that will definitely be on the exam. It's also in one of the labs. Did you guys do that already? Where you had to trace through like a student, I think? Maybe it's the next lab. I don't remember. So the idea is that you make a table, you list all of the instance variables, you list all of the local variables, and when one of them changes because of an assignment, you cross out the old value and you put the new value in there, and you do that one instruction at a time. So basically you play the computer and simulate exactly what the computer would be doing. And all right, so that what good does it do? At some point, then you begin realizing that you're not getting the right answers. Are we already at a spot where we get a wrong answer? So are we already at a spot where we're getting bad results? So we've moved once, and originally the x and y were 0, 0. Let me change colors here. Come on. Originally there were 0, 0. and now it's at 1, 1. With a single move. So this bug can do something extraordinary. What can it do? It moves diagonally, right, in a single move, whereas the bugs that we're supposed to be modeling can only move in the 4 compass directions. So where could that have gone wrong in the code? Yes? Aha. So over here, dx and dy were both initialized with 1, which is exactly the diagonal direction. So what's the fix? Yeah, so which way is the bug supposed to face? Okay, so the first part of the fix is the following, is to document what the heck it's supposed to do. Where is it supposed to face? East, west? East, right? Like all bugs do when they're born. So, and now that we know what it's supposed to do, then we can see that this one here should actually be 0. Okay. So, of course, someone who's very experienced can look at all of the code and see, oh, that's the reason why. But oftentimes, particularly when your programs get bigger, you don't immediately have that kind of experience. After all, otherwise the person wouldn't have asked. And so it's a really valuable tool to be able to figure out what goes on without writing any program, simply by running the numbers by hand. And so running the numbers by hand is an easy thing to do, and it's something that you definitely want to practice. And that, like I said, will be on the exam. And the other thing that you need to do to make sense out of that tracing by hand is you also have to have some idea of what is supposed to happen. Now, we know what was supposed to happen here because the tester told us what it expected. Right at this point, it expected the position 1, 0. And it was here the one that way we had the mismatch. So I do agree it's a little bit tedious to do all of this, right? You have to take out a sheet of paper, you have to make a sketch of the bug, you have to write down what all these variables are, but that is the way that one debugs these programs. Any question about this approach? All right, we'll practice this on one of the labs, and like I said, it's guaranteed to be on the exam, where I'm going to give you some class that does something where you don't necessarily know what it should be doing, and I'll ask you what does it actually do. All right, that should get us to the lecture. Okay, so we're finally catching up with the homework. So providing implementation. So whenever you have any kind of class at all, the first thing you do is you ask yourself, you already know what methods it's supposed to have, because when you design the thing, you start out with writing down the method. So the bank account, we know it has deposit, withdraw, get balance. So the first thing you need to ask yourself, what instance variables do you need to have? So in this case, for the bank account, we just need the balance. Maybe we can practice this to make it a little bit less abstract by looking at one of the new homework assignments. So in the first homework assignment, we're supposed to be making a bug that can turn in arbitrary directions, so that 45-degree angle bug that we've just seen, that is in fact possible. And so a bug like that has a position, of course, and it has a direction that can be absolutely anything. So the position you would denote with variables x and y, and the direction, the easiest way of doing it, well, there's two easy way of doing it, and I'm not sure which one is easier, but the one that I've suggested here is to use the offset in x direction and the offset in y direction, just like we've done before, simply because you're familiar with that representation. So in this case, we would say the instance variables of the bug would be double x, double y, double dx, and double dy. Why double? In this case, they can easily be fractional values, because when you have a bug that turns like by 29 degrees and then walks forward, that's going to get some non-integer values for x and y. Yes, so let's look at another way that you could do it. You could do it with a slope, but that would be working kind of hard, because when you have a particular slope and then you turn, to compute the new slope is hard. But what would be a really good representation that would make turning pretty easy? What if you stored that angle, the angle between the bug and the x-axis, say? That would be a perfectly good representation of where the bug is. And why do I say it's easier? Because now turning has become pretty trivial. If you have a given angle, and then you want to turn by an amount, all you have to do is add that turn to the angle. So that might actually be a better representation. And so it might be a thing that one might want to do is to change from one representation to the other as one realizes that. And that's all good, because the representation is private. As long as the outside doesn't know, there's nothing wrong with doing that. All right, so even choosing the right representation is sometimes not totally obvious. Usually it's pretty easy, but sometimes there are better and not so good ways of doing it. All right. Now let's say we have a representation. In the bank account, we just had the balance, and that was it. And so the next step is to implement constructors. To implement a constructor is almost always perfectly easy. The rule of thumb is look at every instance variable and initialize it to something, and preferably initialize it to the appropriate value. That's where the previous code went wrong. So here we were in the constructor, and the particular constructor initialized dy, but it didn't initialize it right. And so that's a common error to make. And so you want to make sure that you don't omit any instance variables, and that you initialize them with the right value. Now, omitting the initialization was something that also happened to someone in Piazza whose bug2 constructor looked like this. Everything else was correct, but the constructor looked like this, and the student asked, how come my bug is not moving? And so the cruel thing is then the poor student kept looking at his move method and thought that the move method was wrong because the bug is not moving. And other students assured him that his move method was just fine. So the problem here is that because dx and dy were not constructed, they got initialized with 0. An instance variable that's not constructed starts out its life as 0. And so then the move method busily added 0, 0 to the current position, and of course moved nowhere. Looking forward to the exam, by the way. That's another thing that you're going to be seeing on the exam. There'll be questions that say, what's the bug? And I don't mean the bug class but what is the error in the code, where it's going to ask you to look at code that has some errors and identify the error. Yes?
The system automatically initialize these variables.
Right. So it didn't, yeah, we haven't really seen that case yet, but we will in a bit. With numbers, they are automatically 0. What's that?
It says it automatically does it, but it's added to your code, or is that just an
Well, it's not actually added to your code because it's a fast thing for the virtual machine to zero out all storage when it makes the object. All right. So notice that here we have 2 constructors, and the second constructor here has a form that's very, very common, where you're constructing an object and you're given the initial state. So we might have the same thing with a bug class, where you might have a constructor public bug2 so we have the x and y of bug2. And so we just want to have bug2 start out its life at an arbitrary position x and y. And now in the constructor, I have a problem. Namely, from the previous slide, the name of the instance variables were also x and y. And so what you sometimes see students do is do this. And that naturally doesn't work, because now there's an ambiguity. What does x mean? Is it the instance variable x, or is it the parameter variable x? And in a couple of slides, we'll come up with another solution to it. But right now, the cheap solution is to change the name of the parameter variable and call this one here initial x, call this one here initial y, and then over here, same thing, equals initial x equals initial y. And then it's unambiguous. Then the initial x, initial y are the parameter variables. So that cheap trick of renaming the parameter variables will always work. Sometimes people use initial. I've seen people say an x, a y, some x, some y, whatever. It doesn't much matter. x1, y1, what you call them, as long as they're different than the instance variables. Okay, I don't want to go through this. Okay. Then you implement methods. And I generally encourage people to start implementing those methods that do something interesting. Most classes have some tedious and boring methods, get balance. And those are generally not worth implementing right away. They're easy enough and you don't gain much insight from it. But implementing deposit here is interesting enough. For the bug, implementing move is interesting enough. All right, so here this method call, you've seen this now many times. I don't have to go through that. Here we have withdraw and get balance. And that's really all. All right, so now we're finally going on to a clicker question. We set up Piazza, and you guys should too. Oops. How do I do that? So here we want to make a change to this class, and we want to make the bank account a bit more realistic. You know, my bank account has a account number. And so I'm adding an instance variable, private int account number. And where do I need to update the methods? There's three methods and 2 constructors. So I guess here I should actually say in the constructors, because there's more than one constructor. Frozen. All right. So let's just set this up in BlueJ really quick. Get the existing bank account class. Oh, account. So the idea is, yeah, we have the account number. And now what should we do? We have, should we change the constructor? Or the constructors? So that seems to me the most natural way to set the account number. We do need to set it somewhere. And so when you create an account, it would make a lot of sense to say, you create the account and this should be its given number. So let's do it. What should I call it? I call it an account number. I don't want to call it initial account number because it never changes. So here I said it. What about that other constructor? Do I also add it in there or no? Yeah, I do, because I call one or the other, so I really should put it in both. So here we have an initial balance. Should it be the first or the second parameter? It doesn't really matter. It's a question of, you know, how do we feel about it. Java doesn't care. So I'm making a bank account with $10,000, and I'll call it number 1729. I just set it with a second, so that's what I'll do. Okay. What did I forget in the constructors? Yes, I didn't say what it is in the comments, so the grader is already getting excited here. So I have to put it here, so it's an account number. The account number, I know this is boring. So, but we do it anyway. It's good software engineering habit. So I have to put it here, and then I can just paste it here. So now the constructors are good. All right, what about the deposit method? Do I need to put in the account number? I mean, after all, when you go to the bank, you say, I would like to make a deposit of $1,000 into account number 1729. Well, it's different in the bank. In the bank, when you say, I want to make a deposit of $1,000 into account number 1729, then the bank somehow gets account number 1729, and after it has gotten it, then it puts $1,000 into that. But from a point of view of modeling this with an object, the object already is a specific account. So if I want to deposit, by the time that I deposit, I already have a specific account, and that already has exactly one number. So there might be a find operation for the bank class that finds this account, but for the deposit, it doesn't make any sense, because you're depositing something into this particular account. And yes, this is the particular account with 1729, but that's already known, presumably, when you hold it in your hands to make the deposit. So no, you don't change those. And I do realize it's confusing. So let's see whether I did manage to confuse people with it. Yes, I did. So these 38 people, trying to see what's a good way of explaining this. It may help if you visualize this particular account. It has a balance, of already $1,000, and it has a number of 1729. And now this particular account, and no other account, we want to execute the deposit method on. We don't care about any other accounts. This account, we want to deposit $1,000 in. And so we can just put it in here. There's no need to even worry about the account number for the deposit operation. For other operations, there may be the need to do it, but for the deposit one, there isn't. All right. Yeah, I have another one. Okay, more practicing of writing methods. So the rectangle class, and it really does have 4 instance variables named x, y, width, and height. I checked it out. And which of the following is here an appropriate implementation of translate? Set up the question. Oh, the answer was 1. For the previous one, the answer was 1. So you don't change the deposit and withdraw. All right, so see how one would settle a question like this. So the best way of dealing with this is to come up with an example. Let me see if I can erase this. So I have a rectangle. That's an icky color. And I want to translate it, meaning move it, by... it wasn't very good. So this would be my dx, and this would be the dy. I want to move it by this amount. And now let's see what the various pieces of code do here. So the first one says width equals width plus dx. Height equals height plus dy. What does this one actually do? It grows it. It makes it bigger. Or smaller if dx dy are negative. But it changes the shape of it, so that can't be right. All right, so the second one is too long. I don't want to look at it. The third one says x equals x plus width, y equals y plus height. Why can't that be the right solution? It doesn't use the parameters. Very good, the gentleman in the front row. Right? So it completely ignores dx and dy, so it couldn't possibly be doing the right thing. It'll do something weird. It'll move it by the current width and height. I don't even want to understand it, but it doesn't do the right thing. Okay, number 4. Why can't it be right? It doesn't change the instance variables, right? It only changes the values of the parameter variables. It doesn't change the instance variables. So it doesn't, if you don't change the instance variables, the object is undistinguishable afterwards. Nothing has changed to it. So by sheer elimination, it must be number 2. And let's see if it is. So yes, so we compute the x plus dx, make this detour into nu x, then move nu x into x. That's fine. That's just a slow way of doing it. And the same thing for nu y. So 2 is in fact the correct answer. So let's see how we're doing here. And so, there was a good number of people who want to rethink their answer. So walk through this thing and really make sure that you understand these things. It really is important to have a crisp understanding of what all of these 4 options do. All right, unit testing. So we've seen this last time with testing an existing class. Now we're doing it with testing a class that we've written. So when you make a test, and you've seen these things more often than many people who read this book, one writes a tester. The tester makes an object, hits it with some methods, prints out what happened after hitting it with those methods, and then prints what should have happened. And so I don't really have to go through this in great detail. So for the bank account tester, let me just put this together real quick here. That's in the book. And it's a much easier example from things that you've seen in a more complicated way. So the tester makes a bank account, exercises some methods. We deposit 2,000, we withdraw 500. So we're seeing how much do we have now. We expect to have 1,500, and so that's what we say. So then we run it. Why doesn't it run? Why does it say no suitable constructor found? Because I just changed the constructor for the previous exercise and added an account number. So let me just add an account number here to go with the flow. And that's good, right? We get what we expected. NetBrad is smart enough, by the way, to know that 1500.0 is the same number as 1500. And someone also asked, Now, why did I get out of homework 4A? Someone was jumping ahead a bit. Someone said, how come it said like 0.000000001 or some such thing, and then expected 0? And NetPrad is smart enough to know that 0.0000001 is the same thing as 0. So when two numbers are almost the same, then NetPrad will consider them the same. So when you get that, don't worry about it. Those round-off errors are completely unavoidable. When you start dealing with sines and cosines and square roots, you're always going to get answers that are approximate. All right, so that's a tester. Let's just ask a quick question about testers. Should be really quick. Oh, it says I don't want it to be a self-check. I want it to be a clicker question. So I'll call this clicker question 3. Set it up. And hopefully that'll be a really easy one. Clicker for 7. Clicker question 3. West Blue Jay. Okay. Oh, the options. Can you do this a little faster? It's not a hard question. Well, let's help this along a little bit. So in the bank account tester over here, what does it do? It constructs a bank account. So that rules out 2 of the answers, right? So there's a bank account. And so we know that 1 is wrong, and we know that 2 is wrong. All right. So the question is there an object of type bank account tester, yes or no? Let's see what the majority opinion is. The majority says no, but there is a minority that says there is. So let's look at the bank account tester class. Main starts. It makes a bank account, deposit, withdraw, printing. The bank account doesn't make a tester class. The bank account doesn't even know that a tester class exists. So any tester that would be made would have to be made in the code that you see right here in front of you. And as it happens, when you call a static method, like here the static main method, it doesn't make an object. So when a program first starts out, it starts out with no objects at all. And until you start calling new a few times, you don't have any object. So there's no object of class bank account tester. So you might say, if I have no objects of class bank account tester, why do I even need the class bank account tester? Because the mission of a class is to make objects. But this is the one exception to that rule, that every program needs to start out with some class, even if you never have any objects of that class. So the correct answer is no testers, one bank account. All right, last thing for the day, local variables. Someone asked about this a couple of lectures ago, actually, so I'm glad we can finally clear this up. So a local variable is declared in the body of a method. In chapter 3, there is an example of a cash register. The cash register accumulates in instance variables payment and purchase, how much the customer purchased, how much the customer paid. And then there's a method called give change that figures out how much change the customer should be given. And it also, when giving change, it zeroes out the purchase and payment so that if you call give change again, it doesn't give the change twice. So here it computes payment minus purchase. It saves it in this variable change. It then zeroes these two out, and then it returns the variable change. This variable here is not an instance variable, so it doesn't belong to the cash register object. It only belongs to this method, and when the method exits, the local variable, as it's called, goes away. So first of all, let's ask, why did we make a variable in the first place? Why not simply do the following? Why don't we just return payment minus purchase? No. What would happen with the code as I just wrote it? It always returns 0, right? You would hate such a cash register. So what happens is, because we cleared out the purchase and payment amount to be ready for the next customer, then it's too late to compute the difference. So we have to compute the difference first and store it somewhere. Yes? That's what the original version did, right? What's that? No, when you return, you truly return out of the function. Return means exit the function with this answer. So if you were to put the return up here, that's an interesting question. So if you were to put return payment minus purchase here, then these ones here would never get there because it has already returned. There's no way of saying, I want to return this value, but I'm not quite ready to return, other than to put it in a local variable. So if you are in that situation, and you often are in that situation, that you need to compute the return, then you need to make some other destructive change, then the answer simply is make a variable, save it in there, and then return that variable later. All right, so the other thing that I could have done is I could have made this thing into an instance variable. So I could have done the following. And in the cash register, which I'm going to have to cram in here, I could have said private double change in addition to private double payment and private double purchase. So I could have set it up like that, and then change would have been an instance variable, and everything would work. But it's considered not a good thing to do, because we don't want to have the value of this change for any longer than the give change method. We don't want the object to have to remember it for longer than that. And so the rule of thumb is that you want to make a variable local when you can, when the value really only needs to be remembered for a single method. It's considered bad form to do otherwise because the reader of the class then says, gosh, why does every object have to remember this thing long term? It's confusing, and it also wastes some amount of memory if these objects have to carry that extra information with them. So you generally don't want to do that, but it's something that I see students do all the time. So it's not uncommon for me to see a class that has like 15 instance variables. Just because that student, for every local variable that really only needed to be there very short term, they said, oh, I'll just put him all the way up there. And it's not wrong, your code will run, but it's just not considered good form. All right, we don't want any of this. Let's see, do we have time for this? Not really. Okay, these are great questions that you should be studying on your own, but I'm going to skip them in the interest of time. All right, I want to spend a couple of minutes now that some people have left to quickly go over one tricky aspect of the homework so that you make some headway with that draft, and that's the assignment number 3 that I know is going to give people grief. C, not, or is it B? It's that letter. Let's blow this up a bit. So we're having a class that I call mail for lack of a better name. And mail is a factory for the kind of letters that some of you, like that gentleman who just left maybe, get in your inbox, where it says, where do we have it? Where we have where it says dear, and then a variable part, and then it has some amount of sentence, and then inside here it has another variable part, and then the rest is boilerplate again, and then this sincerely, and then this here is another variable part. And so this one is really kind of off the beaten track from what you've seen so far. So far you've seen classes that modeled bank accounts and bugs where the state was some numbers. In this situation here, a mail object doesn't remember numbers, but it remembers strings. So for example, the one that I have here, this is the one for the warning. The warning stores 3 strings. It stores my name, it stores the thing before and the thing after. It doesn't store the name of the student. That can vary. And it doesn't name the particular offense, what was missing. That can also vary. And you see the example over here. So notice that here it's the same warning object used 3 times. So it can create 3 different messages. So you need to ask yourself, what does this particular warning object remember? And I should have put this on here. If someone sends me an email, I'll amend this a little bit to make it clearer. I could have another mail object that says say failed, and that would say new mail. And now I might have a different text that says, I am sorry, you failed. And that would be the prefix, and then the suffix might be, okay, what else might I say? So long. And then, Professor Fiendish. So this would be a different object, and ask yourself, how does the state of that, what is the difference, and what would produce, what messages can this object produce? All right, put questions on Piazza and start coding.